Welcome back to another episode of How to Geometry. In this video, I'm going to show you how to utilize the law of cosines. It's basically when law of sines doesn't work, we analyze the triangle and we see that typically you're going to have a side angle side is going to be the condition that we use, given the information, we got to be given two sides and the angle between the sides, or we're given all three sides and then we have to find the angle. In either case, we're about to get into it right now. So if you haven't done so already, please subscribe, like, comment, let me know what you think, and let's get it. Okay, law of cosines. So when law of sines doesn't work, law of cosines is the next tool that we have. So it says that for any triangle with side lengths ABC, and specifically when big C is the angle opposite of the side little c, then this formula here is true. So in these scenarios, right, you're given a random triangle with random information. Now, for law of cosines to work, right, this would need to be a side angle side scenario. So side angle side. And that's exactly what we have here, right? We have a side, angle, and side. The angle is in between both of the sides. The angle is in between both of the sides. So that's how we know that law of cosines is going to work. Now, I could show you where law of cosines comes from, but I think knowing how to use it is more applicable than being able to recite where it comes from, right? I mean, in pre-cal, the next course, you go in depth more than this video for sure. We're just skimming the surface and just showing you how law of cosines can be applied. I do want to note that in this particular equation, right, you need to know two of the sides, if not three of the sides, because you're typically going to be solving for either little c, and you must know big C. Well, technically, you need to know the other two sides and big C, but for sure, the way that I remember this is that the side that I'm looking for has to be across from the angle that I know. So if you look at the picture, right, here we're solving for little w. Now, little w, it's across from the side, from the angle that we know, right, 49 degrees, which is big W. So in these problems, right, the formula has A, B's, and C's. Nothing says that the problem will have A, B, and C's. Now, if it does, it's going to be ideal. But if it doesn't, that's okay. The side that we're looking for needs to be across from the angle that we know. So in this case, little w, you can count that as little c, and big W, you can count that as big C, capital C. And then the other two sides are just A and B mixed in, like whichever one you want. Like literally, I can assign this to A and this to B, and it won't matter. You could switch them, and it's going to come out the same as what I'm saying. So then, I do want to demonstrate one thing though, right? Let's just say you didn't know that this was law of cosines, and you're so used to law of sines, like, oh, I'm just going to try law of sines. Well, if you tried law of sines says you take sine of the angle over the side across from it, set it equal to sine of, in this case, we can call it h, over the side across from it, which is 41, which is equal to sine of y over 36. Now notice, in each of these ratios, there's not a complete one, right? There's a variable missing in each one. It's no good, right? Like this, there's no way to solve for any of these variables right now by using this method, because you have to have utilized 2 ratios, and then 3 of the 4 variables must be known, and that's not the case, right? So law of sines will not work. I just want to show you that. Okay. So with that being said, this is law of cosines. So let's plug in the information that we know, right? I know that I'm looking for little c. So in this case, it's going to be little w. So little w squared is equal to a squared. So 41 squared plus 36 squared minus 2a, which is 41, times b, 36, cosine of big W, which in this case is 49. Okay, like all we did was substitute all of the values, and we want to solve for little w. So to do that, we have to take a square root of both sides to isolate the w to get it all by itself. So little w is equal to the square root of all of this, and this is for sure calculator work. Okay, this comes out to approximately 32.253 if we truncate it to 3 decimal places. Be sure your calculator is in degree mode for this to work out. All right, so let's look at some more examples. So again, the big takeaway is that the side that we're solving for needs to be across from the angle that we know. And we utilize this formula here. Okay, look at some examples here. So this is angle, side. This is side, angle, side. So law of cosines is definitely the way to go, even though it tells us to use law of cosines. If it didn't tell us, we can analyze and say side, angle, side. Okay, law of cosines. Okay, this is little t, and it's across from the angle that we know. So this is the angle that I'm going to solve for. T squared is equal to the square of the other 2 legs. So 21 squared plus 16 squared minus 2 times a, which is 21, times b, which is 16, times cosine of the angle that I know. And we just take a square root. Straight to the calculator. So t is approximately 13.219. Not bad, right? Not bad at all. I was trying to, again, side angle side. The angle is in between the 2 sides that are given. So little b, that's the side we're solving for. And it's across from the angle that I know. So little b squared is equal to the square of the 2 other sides. 118 squared plus 152 squared minus 2 times a times b times cosine of 25. We'll take a square root because we want to isolate the b. So b is equal to the square root of all of that. Calculator time. Okay, I get 67.208. Okay, here's another example. This is going to be, again, side, angle, side. So, and then little w is the side we're looking for. So sine, no, not sine. So little w squared is equal to a squared plus b squared. So it doesn't matter which one is a. So 87 squared plus 114 squared minus 2 times a, which is 87, times 114 times cosine of the angle that we know, right? The one that's across from w. It's going to be 12. Solving for w, I take a square root of both sides and then to the calculator. Okay, we get 34.094. Okay, side, side, side. These are all side, side, side. So we're missing an angle. We're going to have to find the angle. Now, immediately, we're finding an angle. Inverse trig has to come to mind. It has to. That's the only way. It's the only tool that you have, really, to find a missing angle, is inverse trig. Either inverse sine, inverse cosine, or inverse tangent. It all depends on which angle we're looking for. So, we're going to utilize law of cosines. Remember, here we had the side we're looking for across from the side that we know. So it's kind of going to be in reverse. The angle we're looking for needs to be across from the side that we know. So this is going to be, let's solve for a first. So a is across from 70. So 70 squared is equal to the other two legs squared. 51 squared plus 62 squared minus 2 times 51 times 62, right? This is 2ab. Cosine of the angle that we want, right? Not the angle that we know, but cosine of a. So now I need to start by algebraically moving things to the left-hand side. So that means I'm going to subtract 51 squared. I'm going to subtract 62 squared. So we're going to get 70 squared minus 51 squared minus 62 squared. So those are all cancels. And now everything left is being multiplied. So I can divide both sides by -2, 51, and 62. Now you could technically do them one by one. I'm just gonna do them one at in one move. So -2 times 51 times 62. Okay, and this should equal, right? Because all this is gonna cancel. This is gonna equal cosine of big A. Okay, to solve for big A, we got to take the inverse, right? That's the only way to get to the angle when it's trapped inside of cosine, sine, or tangent. In this particular case, it's cosine, hence the name law of cosines. So I need to take cosine inverse of both sides. All right, on the right-hand side, the cosines cancel, leaving behind just A. So let's go to the calculator. We're going to type all this into a calculator. Inverse cosine, 70 squared minus 51. Okay, this is going to come out to, we'll call it 77 degrees. We'll take it to the nearest degree. Okay, that was a lot of work for just one angle. But let's try it again. So now that we know what A is, it doesn't matter which other angle we solve for. Let's just go for, let's solve for C. Actually, let's solve for B, to keep the letters mixed up. So B is going to be across from 51. This means 51 squared, right? The side we're looking for, or typically the side we're looking for, this is going to equal A squared. In this case, it's the square of the other two sides. It doesn't necessarily have to be A, but in this case, we can use A for A. So 70 squared plus B squared. Well, since we're using B, it's basically the other side square. So C is what I'm going to use. Right. So the side that is out here, it's always going to be across from the side that I'm looking for, right? Because this is going to end with cosine of big B. Well, this needs to be little b if this is big B over here. That's simply what it boils down to. So minus 2 times 70 times 62. And then obviously times cosine B. Okay. We're going to subtract minus 70 squared minus 62 squared. I'm not going to do minus 2 because it's being multiplied to something else. So we'll get to that later. So it's going to be 51 squared minus 70 squared minus 62 squared is equal to negative 2 times 70 times 62 times cosine of B. Okay, I'm going to divide both sides by negative 2, 70, 62. So we're left with cosine B. Now, as mentioned previously, to unlock the B, right, to get to the B, you got to take the inverse. You have to. Cosine inverse. Cosine inverse. All right, and this is just straight calculator work because on the right-hand side, these cancel and B is all by itself. Okay, we're going to get 45 degrees. I will say I noticed I did have a calculation error for the last problem. It's actually 76. Maybe yours is slightly off or mine is slightly off, but it's 76 degrees. Okay. So now that I know two angles, we no longer need law of cosines. We can simply subtract both of these numbers from 180 to find C. So 180 minus 76 minus 45 is 59. Okay. I feel like I'm going to skip over 13, 14. You can feel free to pause the video and work those out. So number 15, the last one. So conceptual kind of question. I'm going to draw my triangle. I kind of draw the same one every time. Doesn't really matter. What does matter, 4, 7, and 8. And now, understanding that the smallest angle is going to be across from the shortest side. So it's this guy right here. So we can call this big A and little a. Okay. We want to find this angle. So inverse trig, right? Inverse trig. That's the only way. So this is going to be 4 squared, right, because it's across from the angle that we want, is equal to the square of the other two triangle or the other two legs, right? The square of this guy, square of this guy. So 7 squared is 49. Actually, let's just put it as 7 squared so you can see it. 7 squared plus 8 squared minus 2ab cosine of the angle that's across from the side that we're looking for. So we're going to call this A. Okay, moving some things around, we get 4 squared minus 7 squared, right? All I'm doing is subtracting. All I'm doing is subtracting. All right, minus 8 squared. All right, now I'm not going to subtract 2, right, because this is all multiplication. So you have to divide both sides by -2, 7, and 8. -2, 7, and 8. Well, they're being actually multiplied. All right, and this is going to equal cosine of A. Now, we don't want cosine of A. I just want regular A. So this means if we take the inverse cosine, it's going to cancel out. We have to do this to both sides because I can't do just one thing to one side and one side alone. Okay, this calculator work. It's the last one. Okay, this is going to be the measure of the smallest angle. It's going to be 30 degrees. Right, using inverse trig. So hopefully you found this video useful. Subscribe, like, comment, let me know what you think in the comments below. And I'll catch you in the next video.